So here's Unit 3. This Unit 3 is about the polynomials. There's a big section on this, probably on your exam, since polynomials involve a lot of different types of concepts. So with this one and solving for the unknown, these two units are probably the biggest two units of your exam. So let's get started. Polynomials. We started polynomials by using algebra tiles. So if you remember algebra tiles, they basically represent your x's and y's in different letters. So remember your square shapes, if that's a square, these ones are always going to be your x square, and there are two different squares. One's going to be colored in and one is not. So remember the one that we use without colors, that's your negative, and the ones that's shaded in, that's going to be your positive x squares or y squares, or whichever one you want to use. And the long rectangular shapes, this one is going to be your just negative x, and the shaded in one, that's going to be positive x, and the little ones, little squares, this is going to be your negative 1, and the shaded in little squares are positive 1. So we use these just to represent your polynomials. Remember, opposite colors represent that they're going to cancel out to make it 0, so you just kind of throw them out. So for this one, we have negative x squared, so that's negative 2x squared plus 1x plus 3. And that's it. You don't have to use the 1 if you don't want to. You can just put plus 1 or plus x. That's totally fine. Next one is going to be plus x squared plus. So these two colors are going to cancel out, so leaving you with 2x minus 4. There you go. Draw algebra tiles to represent these ones. Since I have negative 3x squared, I'm going to have 3 large squares that are not colored in, absence of color. And then the next one is my colored in x, and I have negative 3, so it's 3 small squares. And then this one, 2n squared, that's going to be my 2 big squares. Even though they're not x's, they're still squares. So I use the big squares. Negative 3n, I use 3 not shaded in rectangles, and plus 1, which is a small square. There you go. Next one for C, complete the following type. This is going to be a monomial. There's only one term here. Monomial. Coefficient is the number in front of your variable, so that's a negative 7. And I don't have constants because there are no numbers sort of attaching to it, so no constants. The type, this is 1 term, 2 terms, and 3 terms, so this is a trinomial. And the coefficients are my 4, my plus 1, and that's it. I have a constant of negative 12. That's the extra one that's on at the end. Type, this is 1 and 2. This is a binomial. And a binomial is going to have a coefficient of 8. That's in front of my h, and the constant of plus 14. Next one, this is 1, 2, 3. This again is a trinomial, and the coefficient will be negative 2, 6, and plus 7 has my constant. Write a trinomial with the coefficients plus 4, negative 6, and a constant of plus 74. So anytime I have a constant, basically that gets tagged on at the end. So I'm going to write my constant as plus 74. A trinomial, I need coefficients, so I'm going to say plus 4, I don't know, x squared minus 6x. So this is 1 term, 2 terms, 3 terms. That's a trinomial. I have a coefficient here, in there, and a constant there. Bam. So that's it for letter D. Now adding polynomials. So if you want to use your algebra tiles, this is a great idea. You might want to just use it just to refresh your memory. It's a great idea to know how to use your algebra tiles, but if you don't need to, it's totally cool as well. So when you're adding, subtracting, you need to look for like terms. So like terms, they have to have same exponent, and obviously the same variable. And So the same exponent is the tricky part, because we can all recognize same letters, but it's the same exponent that recognizes the like terms as well. So for this one, we're going to have like term here, like term there. This is 9 squared, x squared, subtract 5x squared, so that's 4x squared. Notice I'm just combining the coefficients, leaving my variable exactly the same. And the next one is going to be negative 3. So this goes back in our unit 1 and combining integers. Notice all the skills building upon each other. Like terms here, I have a and a, those are my like terms. This is just by itself, so I'm going to have negative 2a squared, negative 14a. I don't change the exponent because my like term has just exponent of 1. I just leave them the same, plus 8. Next one, like term, I have one here and like term there because they're c squared. So 6 subtract 3 is 3c squared. My next like term is here and there, so that's going to be negative 4c plus 4. There you go. Next one, like term is here and there, so negative 8n and negative 2n, two negatives. Since they're combining, it's going to be negative 10n. This is another like term, so that's going to be plus 14n squared. You always want to put the larger variable in the front, so I'm just going to rewrite it like that. Next one, next part of adding polynomials involve brackets and adding, or it's addition, an addition sign, sorry about that. So anytime you have to get rid of brackets, the trick here is if you have a positive sign, everything stays the same. So every sign inside the bracket stays the same. When we look at the next part where you're subtracting, we have a subtraction sign. That's when all the signs flip-flop and change into the negative signs or opposite signs actually. So since this one has brackets, I need to get rid of them. And there is an invisible positive sign here because there's no negative. That means it's going to be positive. So to get rid of the brackets, I'm just going to get rid of them, keeping all my signs exactly the same. So that's that. And there's a positive sign here, so I'm going to write positive signs, or I mean leave the signs exactly the same. Once I get rid of the brackets, that's when I can combine like terms. So this is a like term here, like term there, 4x squared, like term there, subtract 3x. Keep pressing the wrong button, 3x. And then there's this one and this one. Again, I need to change my grip. I keep clicking on this little button on my pen that's helping me scroll. Okay, so the next question here, again, brackets. I need to get rid of the brackets. So there's an invisible positive sign. So because of that reason, I can just drop the brackets, keep every sign exactly the same. Notice sign is the same. Positive sign here, that means I can still do the same thing, drop the signs, keep everything the same. Notice my brackets are gone. I can now combine like terms. So here's my like term, negative n squared minus 3n. There you go. Letter C, find an expression for the perimeter. So perimeter is all around the triangle. So in the simplest form, basically you need to find the total of the perimeter. So that means m plus 3m minus 3 plus 2m minus 2. Combine like terms. This is a like term, again because they have the same exponent. They're same exponent, same letter. So 1 plus 3 plus 2, that's 6m minus 5. That's my perimeter of this expression. Next page. Now this one is subtracting polynomials. So subtracting is a little bit different than adding because now there's a subtraction sign. So the trick here for subtraction from addition is that in order to get rid of the brackets, remember we talked about getting rid of brackets and adding, you have to switch everything inside to the opposite. So this was a positive 2x squared, and now it becomes a negative 2x, not square, I mean 2x. This is a negative, so that becomes a positive 2. The first bracket, however, doesn't have a negative sign in front. It still has an invisible positive sign, so everything stays the same. So that's 3x plus 4, just like that. Combine like terms, so 3x minus 2x, that's 1x, and then 4 plus 2 is plus 6, just like that. Here is another negative, so I'm going to switch everything inside here to the opposite sign. So there's a negative 3a squared, so that becomes a 3a squared positive. This is a positive, that changes into a negative. Notice they're all opposite. Here is an invisible positive sign. Get rid of the brackets, stay everything the same, like that. Combine like terms. So 3a squared, this is a like term, so that's 4a squared plus 2a. So that's your next one. Let's look at the next example. Same thing, negative sign, so switch all the signs here. So negative 4k, this is positive, so it's negative 3. This one has a positive sign in there, so everything stays exactly the same, plus 5. Combine like terms, so it's going to be negative 7k plus 2. Like terms. This one's a trinomial, and trinomial with a negative sign, so switch all the signs to opposite, negative m squared. This one is going to be positive 4m. This one's going to be positive m. And then drop the brackets for this. There's a positive invisible one, so negative 4m squared minus 3m minus 3. And then collect like terms. Here's 1, there's 2, so negative 5m squared. And then here's 1, here's 2, so that's going to be plus 1m, negative 3 plus 4, that's a positive 1. Negative 3 and plus 8, that's going to be plus 5. So there's your trinomial as an answer. Create your own polynomial subtraction question, solve it. You guys can totally do that. We're not going to go over that. What is the difference in the perimeter of the two rectangles? So basically, this one is looking at what is the difference between the perimeter of the big rectangle, subtract the small rectangle. So the big rectangle, well, we need to find the perimeter. So that means it's 2x plus 1 plus 3x plus 4. And then since that's only for these two sides, we have to multiply this whole thing by 2 or just add another set with it. So we're going to look at like this, combine all the like terms. So that's 1, 2, 3, 4 like terms. So that's 10x. And then this one is 1, 2, 3, 4 plus 10. So that's the perimeter for the big rectangle. For the small one, it's gonna be 2x plus x. That's for these two sides, and then we're going to do that again for the other two sides. So then this one, all of these ones are like terms, so 2x plus x is 3x, 6x. Okay, so now we have the perimeters, we have to find the difference. So we take the big rectangle, 10x plus 10, subtract 6x, which is a small rectangle, so that's going to be 4x plus 10. So that's your answer. Going on to the next one. Now we multiply now. So previous two things, adding and subtracting, notice, try to recognize the pattern of how you take out the brackets. What do? You combine like terms with the coefficients. Multiplying polynomials is actually easier. This is similar to your powers and exponents, is where when you're combining things with the same base, you're just adding the exponents. So in this case, you have 4x times 3x. The numbers are multiplied, so that's 12. X times x is x squared. Notice the exponent is added. You don't have to combine like terms here. For this one, negative 3 times 10 be negative 30. A times a be a squared, just like that. Now we have this, we have a one monomial, one term, and a binomial with brackets. So we have to go and distribute. So 7 times 3x is 21s, well, I should have said s. 7 times plus 1 is plus 7, just like that. Distribute this one. Answer is positive, negative, and negative, positive. 12h. Negative and positive is negative. 2 times 3 is 6. Now, this one you have binomial times a monomial, same thing. Distribute. So it would be negative 5c squared. Positive and negative would be negative 5c. Notice they're all basically the same stuff. Trinomial, distribute the same stuff. So 2 times n squared would be 2n squared. 2 times positive 3n would be positive 6n. 2 times negative 2 would be negative 4. So not too bad. Distribute again, so it would be 6p squared plus 12p. And then negative 10r squared plus 4r. Notice it's just all distribution. Make sure you're looking at the signs as well. The signs are important. Okay. Find the polynomial expression for the area of each figure. Ooh. Basically, when you're looking at area, I think we covered this in the first video. You're looking at the area. The formula for the area is length times width. So you're going to multiply this to that. So this is actually easier than finding perimeter because you're just multiplying. So that is times to that. Okay? And notice it's a binomial and a monomial. You distribute. 4n times 2n is 8n squared. This is going to be plus 4n. Boom. That's your area. And for this one, we're going to go and solve. Okay, this one's a little bit tricky. You notice these hash marks. What that means is that these sides are exactly the same. So that means that 4D has this hash mark, So this is 2D as well. I shouldn't have said 4D. I keep saying the wrong stuff. So 2D has this hash mark, so that means this hash mark is the same as 2D, and this is 2D as well. So you can sort of break this down into two shapes. This one, the square, and this rectangle. So this square is going to be 2D times 2D for the area, which is 4D squared. Notice, not 8, the exponents are added. The rectangle in this one is going to be 2D times D, which is 2D squared. So the total, now you can add these to combine the total, it's going to be 6D squared because, hey, they're like terms, same letter, same exponent. Next one, we're whipping through this one. Dividing polynomials, separate these binomials or trinomials into separate sort of monomials. So the first one is 12h divided by 6, divide the coefficient. This is going to be 2. H doesn't have anything to divide into except for 1 really, so it just becomes 2h. Next one, negative 18 divided by 6. This is going to be negative 3, like that. 20x squared divided by 2. 20 divided by 2 is 10x squared because x squared has nothing to divide, so it stays the same. Now you have this one, separate this. So negative divided by positive is negative. 6 divided by 2 is 3. M squared has nothing to divide it by, so it stays the same. Next one is going to be negative 10 and 2, so that's going to be negative 5. Getting the hang of this, eh? 6n squared divided by 3 is 2n squared. Positive 3n divided by 3 is plus n. Positive 9 divided by 3 is plus 3, like that. And let's keep going. This is going to be 6ab over g plus 3a over g. Now, this one you might be asking, well, what do we do with the g? It's a great question. Since ab cannot be divided by g and g cannot be sort of canceled out, you just leave it as it is. So notice I have ab divided by g. There's nothing I can do, so just leave it in the mathematical expression of the brackets, or not brackets, the fractions. So same as here, 6a divided by 2g is, the numbers can be divided. 6 divided by 2 is 3, but a and g won't cancel out, so just leave it. So the next one here is 3r squared divided by 3r. 3r's can be canceled, leaving 1r at the top. So r squared divided by r, basically you subtract the exponent, so 2 subtract that 1 is 1. And then here's the negative 6r divided by 3r, negatives 2, and r's get canceled out. That gives you just 2. That's it. Let's see what else is here. Find the polynomial expression for the length. The length, this one you have to sort of work backwards here. Notice that this is a rectangle, so you know the area is equal to length times width. So since you know the area, that can be there, you know the width, you can plug it into there. So if I were to substitute all this stuff in, it would be 4q squared plus 4q. Oh, that looks like a T. This is now equal to L, that's what we're trying to find, times 2q. So if we're to divide 2q to both sides, this is solving for the unknown. This will cancel the 2q, leaving your L by itself. And then now you have just a division question. 4q squared divided by 2q is 4 divided by 2 is 2. Q squared divided by q is q. And then 4q divided by 2q is 2 cubed. So that's your answer. And then same thing for the next one is 12d squared plus 3d is equal to L times 3d. And to solve and isolate for L, I need to divide by all the other stuff, which is 3d. Cancel, cancel, leaving you with L. And then this is your division question. So 12d squared divided by 3d is 4d plus 1. That's your answer. So that's your unit 3, just like that. So make sure you know how to see the rules, as in multiplying means you add the exponents, dividing means you take away the exponents, and when you're adding and subtracting, you need to find the like terms. And takes practice. I'm sure after you have done a couple of these ones, all of them are pretty much similar. Make sure you're recognizing the pattern. So that concludes Unit 3, and look forward to Unit 4.